Hi everyone, let's take a look at problem 6-1, which is a bond valuation yield to maturity problem. Callaghan Motors bonds have 10 years remaining to maturity. Interest is paid annually. The bonds have a $1,000 par value and a coupon interest rate of 8%. The bonds have a yield to maturity of 9%. What's the current market price of the bonds? Okay, let's solve this in two different ways. Okay, first, let's get some of the variables we need here. Okay, time until maturity is the number of periods, and that's 10 years. Let's bring some other factors we'll need to light. Yield to maturity, YTM, as an abbreviation, would be the interest rate, and in this problem it's 9%. The bond par value, or the future value, is $1,000. In the periodic bond payments, let me hit the F2 key so you can see how I calculate that. I take the $1,000 of the bond par value times the coupon interest rate of 8%. Okay, now let me go ahead and put a formula in to show how we would calculate this using Excel's present value. I'm going to type in equal present value, and you see we get a little pop-up screen using the latest version of Excel. If you click on the formula bar, we'll get a whole pop-up where we can look at the parameters we need. Okay, so I'm going to slide this over so we can see this. The rate is going to be equal the market rate, or the yield to maturity rate, of 9%. The number of periods is the 10. Okay, the payment amount, and I'm going to enter this as a negative, and that way the present value will come out as a positive. Keep in mind the way Excel works and the way calculators work is it takes the present value minus the future value to equal a zero amount. So you have to consider the signs in how you work through these financial formulas. Okay, so the payment amount is going to be equal a minus $80. Okay, anything else we need to know? The future value of the bond is the $1,000. Again, I'll enter that as a negative, saying that these will represent, if you will, outflows, so the current market price would be generated in a positive number. You could always go the opposite way and then flip your final answer to turn it into a positive number. Both ways will work. Okay, and we come up with $935.82, so there's my formula. Okay, now that's one way to solve the problem, but we could do it another way as well. We could drop in time and cash flow, okay, and let's see, drop the number of periods down here, and then determine the current market price. Okay, but now for those cash flow, it's $80 in every period, right? Other than the last one. The last one, we would have to be, let me hit the F2 key, and I'll type it in, let me just type it in here. This would be equal $80 plus the bond par value of $1,000. Okay, so in that last period, it's going to be $1,080. Now, we could use the net present value formula to come up with this problem. Equal NPV. Again, we get the little formula, and then it's looking for a rate and some values. But let me hit the F2 so we get the pop-up again. Okay, so the rate I'll take from there, current market price of the yield to maturity, 9%. And then the values, now we could type them in one at a time, or you could just simply highlight all of them. Instance, all of those values are representative as inflows. The NPV formula doesn't behave the other way and give you a negative number. It actually gives it to you in the way you expect it. Okay. And now if I bring that to light again, we get 931.95. Oh, my mistake. We do not have a cash flow in the beginning period. There's no cash flow there. So once I eliminate that, you see that we come up with the same answer through both techniques. Okay, so one, the more direct way, you can use present value where you enter the various parameters you need. And the one way to lay it out by the cash flows, we can lay it this way out and use the net present value, and both of those will work. Okay, I hope you found that beneficial, everyone. Thank you.